Hello, my name is Samuel Lotto. I am a senior electrical engineering major at UW-Platteville, and I am enrolled in the Intelligent Controls course. This is my game I produced for Lab 2. My game is titled Paint-A-Crate. Now for a quick overview of Paint-A-Crate. We will begin with taking a look at the general format of the game, and then we will discuss the approach or solution to producing this game. So first, looking at the format of this game, it is an assembly line game. So a crate passes through a conveyor system, stopping at several stations to be painted. The game produces a target product that the user must match. The crate passes through several quality control points. So a random crate will be generated at the beginning, either a broken or intact crate. The user must determine whether the crate is broken or intact and successfully determine whether it should be incinerated or pass through quality control. The crate then visits 3 painting stations. These stations correspond to the 3 primary colors: yellow, blue, and red. So, if a user's target product is an orange crate, then they will need to select the crate to be painted at the yellow and red station, excluding the blue station. They will do so by using a thumbs up or thumbs down gesture with their hands, as detected by a teachable machine model, which we will discuss later. This same mechanism is used for determining whether the crate is to be incinerated or pass through quality control, as decided by the user. There is also a station where the user determines the number of white stripes to be added to the crate. The number can include 0, 1, or 2 stripes. The user will input their decision based off of the target crate by holding up the number of fingers corresponding to the number of stripes. Now, as I have mentioned, as we look at the approach or solution to this game, 2 teachable machine models were used in producing this game. The first one was the thumbs up or thumbs down detection. The second one is a 0, 1, or 2 finger detection model, which we will discuss further following this overview. This game was also completed using Scratch programming, MIT's Dancing with AI platform. The game was also made with fully custom graphics using pixel art. Now let's take a look at our first teachable machine model. This model was used to detect thumbs up or thumbs down hand gestures made by a user. This was accomplished through image recognition and supervised training. As you can see here, the model contains 3 classes: the none class, the up class, and the down class. A thumbs up hand gesture is trained to be placed in the up class. As you can see, that is being successfully accomplished here in the image. In likewise fashion, the thumbs down gesture made by a user is classified as in the down class. Any photo or imagery coming into the webcam that does not contain a thumbs up or thumbs down gesture is placed in the none classification. This is vital in order to avoid improper user input during gameplay. And now our second teachable machine model. This model was used to detect the number of stripes the user wished to add to a crate. This was accomplished through image recognition and supervised training. As you can see here, the model contains a none class, a 0 class, 1 class, and 2 class, or 4 classes total. If the user were to make a closed fist gesture like this, it would be placed in the 0 class. This indicates that the user wishes 0 stripes to be added to the crate. In likewise fashion, 1 finger up would be placed in the 1 class and indicates that the user wishes 1 stripe to be added to the crate. as well as 2 going in the to class and adding 2 stripes. If none of these 3 gestures are made, the camera input is classified in the none class. This is again vital to avoid improper user input during gameplay. Now let's take a look at the code written for the game. This was accomplished in MIT's Dancing with AI platform, or Scratch. As you can see here, this is the code corresponding to the user-controlled sprite. This sprite will randomly generate with a broken or unbroken costume with a corresponding costume number. This code controls the position of each station throughout the conveyor belt system. It also uses user inputs of thumbs up, thumbs down, 0, 1, or 2 fingers to make logical decisions at each station. The station will not, or the sprite will not progress to the next station until a user input has been made, and its action will follow the user's input. An example of this would be if the user were to give a thumbs down during a quality control point, the crate would move into the incinerator. But if the user were to input a thumbs up, the crate would continue on to the next station. Now let's look at the code used for controlling the target sprite. This sprite indicates to the user what the target product is. This code randomly generates a costume number, which then changes the costume of the sprite to the corresponding costume. This is accomplished through a lot of embedded if-else statements. This code is also used to compare the costume number of the target sprite and the user sprite at the end of the game to determine whether the user has won or lost the game. Here, I'm just going to simply highlight the code that is used to control the corner operator sprite. This sprite simply tells the user to begin painting the crate at the beginning of the game, as well as indicating whether the user has won or lost the game. This is the code used to control user input. This injects the teachable machine models we discussed earlier into the game. The output classification of each model is used to change the value of variables that are used in the user sprite code to control what happens to the sprite. So this is how the user's input ultimately controls the sprite. Here's a quick demo of the game in action. As you can see, the target sprite is a red crate with a single white stripe. As you can also see, the game randomly generates broken or intact crates. The user must determine whether these should be incinerated or pass to the next station. At each station, I give the proper hand gesture, thumbs up, thumbs down, 0, 1, or 2 fingers, to tell the game what should happen to the crate. As you can see here, I successfully win. Here is an example of the user incorrectly allowing a broken crate to pass the first quality control point. Just a quick look at some of the challenges faced while producing this game. There were difficulties in training the models with Teachable Machine. These difficulties included issues of poor classification as a result of changes in lighting or changes in my outfit. To combat this, I took samples in several locations with several different outfits with different amounts of light. This definitely improved the model, but there are still errors when I am in new locations. There were also challenges with using Scratch and the MIT Dancing with AI platform. The first would be embedded if statements. Because there is only one else statement following an if statement maximum in Scratch, It was very difficult to keep track of which embedded if-else statement I was in, as I had to embed a lot of these. There were also some learning curves when it came to aspects such as messages within Scratch because I had not used the program prior to making this project. With all that in mind, the project successfully made a video game that is playable with image recognition with user input. I will finish this video with 2 more quick demos, one with another successful win and another with a loss. Thank you.